get the force BC tak macam ni? Can we find the force BC? That will be the tension of you punya link BC, because this is our link BC, right? Plus, for example, this is your rod. This link BC, let's say this is a cylinder. Cross section is cylinder. The link BC. So we need to know the BC. This is the BC. So you don't have to BCY. You don't have to do, if you take it like this, BY, you take the free body only on link BC, it could be complex. This one also link connection. This one, if you look on this kind of question, so we have BC. If you take the BCC, also have CY and CX. So not necessarily you have to solve it like this. You just take the free body diagram from the handle itself. The handle itself. So how do you solve the force BC? You remember this one, the BC is the tension force, right, guys? Are you with me or not, class? So it means your rod BC will be, this is your FBC. Are you with me or not? Do you understand or not?
Yes.
Class? Are you there?
Yes, Doctor.
Okay, boleh fokus video nampak je lah. So you take the handle for liberal diagram, and how do you solve BC here? Based on the dimension given here. Everything is there, right? So we know the angle here is 30 degree. Okay, 30 degree. And we know this one is a 50 millimeter. From here to here is 50. Okay, 30 degree and 60 degree there. So this one is 60 degree. This one is 60 degree. So this one also 30 degree from here. 30 degree from there. So my point is you can solve for BC here. Okay, this one I don't need to explain. I need to say how you can understand. So that's how they solve it. Macam for example like this one, if you look on the solution, they took the free body diagram here first, then they can solve for the FBC. They can solve for the FB. This what they call here is FBC. FBC. So FB is this one FBC. FBC here. So they take the moment from here. You can take the moment at point A, right? Okay, you take the moment at A, counterclockwise is 0, so you can get the 120 because moment is at pivot. You don't have to solve for AX and Y. You just need to find FBC. Moment at A is 0. So since is 200, 300, right? 200, 300 is because our force is perpendicular to the distance here, 200. So 120. So negative 120 Newton. Okay. Negative because counterclockwise times 500 millimeter. Okay. We have 100 negative because that go for clockwise times 500. Okay, 500 millimeter. Then we have FBC is positive or negative moment on A. Untuk clockwise positive plus FBC the tension times. So what is the distance from here to here? So given from distance from there to there is, if you look the distance from this diagram, the distance is what? What distance from FBC? FBC is straight way down, but the distance FBC ni to A ni, what is the distance there? Guys, are you with me or not? Berapa distance dia? Ini 30 degrees guys, ini 30 degrees and the distance here is given 50 millimeter. How do you FBC at A tu berapa? Moment at A. FBC times 50 or FBC times 50 for sin cos apa ni? This is 50 millimeter. 30 degree from here. Class. Hello class. Kau ni dengar apa saya cakap ni? 30 degree. FBC time berapa? Why the distance ni? The distance horizontal because this force is downward, right? So what is this 120 Newton? Is not, we take because it is perpendicular to the 200, 300. So 120 times 500, that one produce negative moment at A. 120 times 500. What about this FBC? Times 50 or times 50 cos 30 degree? Because it's straightward. The distance horizontal, right? Perpendicular to your force. Remember, guys, FBC. This is your A is here. The distance here is 50 mm. but the angle is 30 degree, right? 30 degrees. So FBC time this distance, right? Plus this distance what? Is 50 cos 30 degrees. Okay, plus FBC times 50 cos 30 degree equal to 0 decimal. So straight away we can get our FBC, right? Third class. Kelas, are you with me? Boleh dengar nampak saya punya video ni? Kelas.
Boleh Doktor.
So, okay, that will be your link BC. Katakan you want to find that will be your link BC. So your link BC kalau tu lah, then you find safety factor DET. So you mean your rod BC will be in tension mode. Because it's like this, it's pulling, right? It's pulling. So you mean your rod pull this go reverse direction because we join it becomes 0. So this one will become, because this is from your handle is this direction. So you mean rod BC is pulling. So you mean intention. Because the erection the tension from FBC to your handle. So it's like this, but your rod FBC must be reversed. So it's pulling, it's pulling your FBC is intentions. Clear? Ni faham guys? Why is it intention guys? FBC intention.
Can you explain again how we got a 50 cos 30 that one?
Because can you see can you see this one? 120 Newton, moment at A. You don't have to solve for AY, AX. You just need to link tension at BC. Moment at A is 0. Alright? So you don't have to find what is because it's spin joint. You don't need to find AY. You think your time. You need just to find what is the tension at rod BC. Okay? So 200, 10, 300, 200. Okay, this one moment at A, so we have 120 Newton times 500 Newton. Because why 500 Newton? Because the force is perpendicular with the distance 500 millimeter, sorry, not 500 Newton. This is 200 from A, right? From pivot A. 120, so negative 120 times 100 millimeter. Because summation of moment is 0. This one, because FBC is this downward direction. Because if you look my live video, I assume it's downward, it's pulling. So it's force, so this one is pulling, so downward. So it means in tension. This is reaction from rod BC to this joint. So 120 times 500, and this one, you nampak tak? This is your, I zoom in, look at my sketch. You punya, I zoom in at the portion yang tu. Okay, it's given that this distance from B, this pivot at A, is given from the diagram. This is 50 millimeter, and the downforce of rod FBC is downward because the rod is vertical. Okay, this is your tension FBC. So the angle is given here is 30 degree. Nampak tak 30 degree? Since because this is 60. This 60 yang balance from horizontal is 30 degree. Clear or not? Just now we have macam ni kan. We have the handle like this. Okay, we have our handle is like that. So we have 120 Newton. This is berapa tadi? 200. Because this 200 and 300 millimeter is perpendicular with your force. So they will produce 120 times 500 moment at A. Because of pivot at A. It means summation moment at A equal to 0, so 120 Newton. The sun did produce, because I assume counterclockwise positive, this is produced moment at A, this is produced clockwise, so 120 times 500, because it produce negative moment, but moment at A. But this FBC produce counterclockwise positive plus FBC that we want to find times the distance. The distance will not be 50. The distance is the distance perpendicular to your force to the pivot moment A. This distance. Clear or not?
Oh, okay, I understand, Doctor. Thank you, Doctor.
Yes, 50 cos 30 degree. So you got your FBC. Okay, you got FBC. So this FBC, this is from the handle, but from the bar itself, because the bar is jointed to your FBC. So the link BC ni, the link BC ni, it going to be in tension mode, not compression, because the bar is connected to the handle, okay, connected to the handle, because the handle this is tension force, reaction upon the force. So it's assumed, okay, everything we got, the downward is positive. But the rod will be connected here, so will be reverse direction. So this one will be in tension. So this correction, it could be rectangular, it could be this. So you find your DET. What is DET? Find the safety factor. So it always given what is the SY value, right? Material must always be. So what is this safety formula DET apa? SY over sigma equivalent, right? Class. Tak, class. Safety factor, class. Are you with me?
Yes, sir.
Find the rod BC safety factor. So SY always given. What is your sigma E? Sigma E is normally from this case we have what type of stress do we have here at the link BC? Do we have torsion stress? Do we have shear stress here? Do we have torsional stress?
Oh, no, Doctor.
So what type of stress do we have? Do we have
Axial.
bending? Yeah, just axial stress. We don't have bending, just a direct axial. So stress here we have, okay, sigma, what is sigma E? Sigma E is your, if you have biaxial lah, sigma x square plus 3 tau xy square, no tau xy 0. So sigma x is your sigma axial, right? Sigma E is your sigma axial square, kan? So what is your sigma axial? Ini tak ada stress concentration. Kita we are not still on fatigue. Kita just basic sigma axial 4F by d square 4 round. Sorry, 4 round. Kalau rectangular, 4 sebagai area. So that will be your sigma E. So you got a safety factor, you got a safety factor. Okay, class, boleh Right? Okay, we go for soalan fatigue lah. Because I just need to, bukan not necessary question will be on shaft. Okay, sometimes this is a thing lah ini yang saya tak highlight you during ini assignment kita. I put that in the our e-learning this kind of question. You look ni lah, you boleh tengok solution how they got. Kalau you still not sure, macam for example this problem ini problem 1.5. Actually this problem 1.5, how they got the point D, this how they solve it. Alright, tengok dia punya solution tu on that macam mana. This is actually from your basic static knowledge and also your solid mechanic strength punya knowledge. Okay, so question static not necessarily always must be sharp. Normally yang fatigue analysis, normally fatigue, I didn't say must always be sharp. Normally fatigue is in sharp. Okay, let's go for our revise balik the fatigue. Okay, fatigue analysis. So fatigue analysis macam mana? For example, fatigue analysis you need to know if on shaft you kena ni lah, you tengok type of question. For example like on shaft, for example like remember yang our assignment like this kan, we have yang ni class. Can you see my e-learning nampak this kind of question kena be familiar lah with shaft analysis your shear diagram. For example, your shaft, you need to the free body diagram of the shaft must be right. You have maybe pulley with tension. You have got to familiar all our assignment that I have given to you. Kan? What is your assignment? I already gave you assignment. What is your shaft assignment? First fatigue assignment. Where is it? Fatigue assignment. Fatigue assignment 2. What is your fatigue assignment 1?
Soalan tadi, Doktor. Soalan tadi.
Ini tak, assignment fatigue only one saja.
Ada dua yang tu. Yang gambar tu.
Mana assignment where is it?
Yang bawah sikit, Doktor. Tu
Ini
gambar
assignment
tu.
2, right? Ini assignment 2, right?
Ini assignment 1. Assignment tu lagi satu bawah.
Mana?
Tu fatigue assignment tu.
Apa kau bagi bubur pula ni?
Okay.
Makanlah bu.
Oh, alright. Okay, assignment 2 into. Be careful lah. Sometimes in shaft, maybe with belt and pulley, tension 1, tension 2, tahu kan? Boleh solve kan yang static analysis. Be careful about lah yang ni, yang your static yang ni, this kind of question must be prepared lah, this shaft of question. Yang ni tahu kan buat you know how to solve this kind of problem, right? Macam ni. Tahu kan? Kelas. Hello kelas.
Apa?
You can solve this kind of problem, like how to
Tidak
get
hanya
tension.
workout
Tension
dia
1,
makan,
tension 2 is 0.15 tension 1. You can get the free body diagram, betul tak kan? So you draw the shear diagram, moment diagram, must be right. If your shear, free body diagram is wrong, shear diagram, the value of your everything is wrong. Your free body diagram, your force reaction is wrong, so your shear moment diagram will be wrong. Be careful. You must be correct from the
Tadi
starting.
aku record guna OBS.
Then
So,
there are
aku tak
shaft,
capture
normally shaft,
baik.
shear diagram, moment diagram, you solve it. You got all the okay, shaft we have shoulder, maybe we have groove, right? Which one yang
dia kan
ketiga?
capture
Always
Windows.
read the question. Jangan, do not
Ni
panic, do
Windows.
not see the question that is
Bukan mic
you
yang-
panic already, do
mic
not
yang
panic.
kita
Just read.
cakap
Sometimes
lah.
the question is actually simple, easy question.
yang
Sometimes it's
button.
given.
Ini
Sometimes you have
nanas.
to okay.
Eh,
Which shoulder is critical?
nasi
Shoulder,
dia
maybe
macam
we have shoulder, maybe we have groove.
Dia tengah record. Dekat
Maybe
ini
we
ni
have
banyak tu
certain
rupanya.
notch. Tengok which one along the shaft,
Dia tu ada
which one is
yang example
critical.
tadi semua banyak kat
So
e-learning tu lah.
that's why the first thing that we should do, we do the FBD, right? Okay, FBD, make sure you order like this, then you draw your FBD, you got all your force reaction, all your force reaction like AY, AI, then you draw your shear diagram, okay, your shear diagram, your moment diagram, then maybe your torque, if they have torque diagram also must be drawn. Torque diagram XY exactly is the same. Sometimes the question will be one plane, sometimes maybe two plane. If you are lucky, it's just one plane only. Maybe XY or Z plane. If two plane, be careful. You combine moment. Remember of both plane, XY plane and Z plane. Okay, then okay. After you draw your shear diagram, you know all. Find moment. Find moment. Combine moment. If you have two plane, be careful. Two plane XY square plus moment XZ plus square root of that. Okay, find the moment. Apa kita cakap critical. Find the moment at critical point. What is your critical point? Actually, critical point is not at the maximum moment. At the shoulder, maybe at the groove. Remember tak your first assignment of your fatigue kan? We have groove, we have shoulder, right? That's itu. Tapi look which one. Maybe there are two shoulders. Which one is critical? Macam tu lah. Tengok which have the greatest moment. Because shoulder is not at the point of your pulley. Shoulder is a little bit offset at certain dimension. Understand tak, class? And not if you look at your moment diagram, it could be like this, right? Kan? It could be even in the negative also. If the magnitude is much greater than positive moment, so the negative side to incompression, that is most critical. Understand? That is not your shoulder. Shoulder could be, you remember, 10 millimeter offset, right? Where is the shoulder at your point, not at the peak moment? I hope you understand what I'm talking about. Do you understand or not?
Yes.
Faham? Not okay. Your moment diagram to because there will be your bending stress. Remember, for shaft 32 moment pi dq, that will be your bending stress. So that point of your critical moment is the location of your gear or maybe your pulley. But the shoulder or maybe the notch, it will be offset at a certain distance. So you need to use what we call it, the ratio of the triangle to get that moment. Clear or not? Class, just like your assignment. Your first assignment of your fatigue, or we discuss, because I tak bagi you assignment banyak, tapi we've been discussing, we already discussed during my lecture, my sample problem. If you look at my recorded video, you will understand.
Record video dia.
Okay. Okay, then you have which one is that critical point, then what will you do, then only you be careful about KF. Remember what is our fatigue stress concentration factor? The formula is, be careful, bending, we have bending. Okay, that critical point, at that critical point, jangan buat semua. Which one critical? At shoulder, maybe not. At that point, okay, critical point. Then we go for bending. Okay, and you got your moment, total moment. If you total moment, remember, if you have total moment at that point is moment, total moment. At that critical point, moment xy square plus moment at z square. Kalau if you have only one plane, just one plane, you don't have to use this total moment. Okay. Okay, I mean that critical, that moment, at maybe at shoulder, at groove. Be careful at that moment. So for bending, you need to find for bending at that critical point tu, we know the value of the moment there. Moment tu, if we have
Rasa
two
yang
plane, we
di-share
combine
dia
two
ni
plane.
mana dia?
Kalau one plane, just one. Bending, okay, if we have moment, we have bending. Bending, we need to have KF lah. KF bending equal to 1 plus Q bending. KT bending minus 1. So ni you got to know lah. KF bending is a fatigue stress. 1 plus Q is non-sensitivity based on bending. Bending and axial is the same. Okay, maybe the question they have axial force. Okay, normally for shaft ni always at between shoulder tu normally take. Sometimes there is no torque. Axial force, if there is axial, be careful about question. Sometimes they have axial, sometimes they don't have. They just moment. They just have bending and torsion. Tapi torsion, okay, bending first. You need to find your KF bending. If you are lucky, KF bending, sometimes the question is given. You don't waste your time to find this one. Understand tak kelas? Sometimes it's given.
Question tu
Sometimes
yang dah
it's given.
start
You already
main
give you
suka
what is the KF bending.
semua.
You don't need to find all these things.
Oh
So
ni lah,
if
playlist
you
dia
look,
kat situ.
okay, if not given, you have to use the equation. You have to go for the figure. Remember, I already share you the extraction of all the figure yesterday in your WhatsApp in PDF. You can
Ni aku
browse to that. Apa tu? That apa?
Ni
Yang all
playlist
the
ni tau. So semua benda ada
figure
kat
and diagram that involved in your test. Okay, so you need to find for bending. So your bending stress equal normally for shaft. Why shaft ni normally bending is completely reverse. They always have alternate.
kamera tu.
Okay, they only have alternate. That will be your alternate. Is KF bending. If given, you just use that KF bending times your 32 moment over your pi plus. Are you watching? Boleh line okay?
Sampai
Plus.
cantik.
Yes, okay.
Alright. KF bending if given, you have to find it manually from the chapter 4 for KT. QB is chapter 8, non-sensitivity. Be careful your non-sensitivity, your SUT in KSI. Just look on the KSI value, and also non-sensitivity your your non-sensitivity. Your we have two zones. One is for torsion, one for bending and axial. Right? Bending and axial is the same zone. Check for your what is your SUT value. No, your notch radius in your X value, not the X-axis is your notch radius. What is your notch radius? Notch radius is your R, right? R of your shoulder, R of your fillet, your groove, R of your notch, the radius, and your with the graph of your SUT
Boleh kau makan ni juga,
KSI. Okay, so you need to find protable KSI. Okay, if not given, so you have to use like this. If sometimes it's given KF, so you are lucky. So you just put the value there. 32 moment. Okay, this moment is critical. The moment yang critical point, not at the pulley, maybe at the shoulder or the groove. So what is the moment there? So there will be your sigma. Why bending is always for when shaft is in rotating. The bending is bending. Okay, sigma bending stress with time always completely reverse. Because at the point we have tension, we go if the element when the shaft is rotated, we go for compression, tension, and the magnitude is the same, tension, compression. So we only have sigma amplitude for bending, only sigma amplitude, but sigma mean is zero. Okay, sigma mean is zero.
Yang ni apa withdraw
That one for bending. Okay, another thing, what we need to know, do we have torsion? Be careful. Sometimes at certain point, in between pulley, they have torsion. If you're between two gears, they have torsion between that point. What is your location of your shoulder or your groove? Is it in between that two pulley? Remember, you have to draw also torque diagram. Remember, previously, you have shear diagram. I just assume shear diagram. Then you have moment diagram, right? Moment diagram like this. Okay, and you have torque diagram. Remember your torque diagram between point A and B. Either is negative or positive. That's depend on the question. Let's say it's positive. This will be your torque diagram. So where is the location of your shaft reprogram is above? The location of your shoulder or your groove is it within this zone? Then we have torsion. So what is the value torque? You know how to calculate torque, right? Your tension one, actually macam like this example. If you look on this one, what is your torque of this shaft? We have macam this one for this kind of question. For this kind of question, okay, where is your torque? Torque is between A and B. Macam B ni just before B ni, between O and B ni no torque. Just right after B and B, C, A ni we have torque. Just Okay, because A is at the end of the shaft. Sometimes the shaft is like this, the configuration. So between B and A need we have torque diagram. So it depends on the question. Okay. So if your shoulder or your groove is within, so you have torque. Torque ni, my point, what is the value of torque? Torque is 100 macam like for example 1000 Newton times the this is diameter times 200 minus, because this is positive x, right? Yeah, positive x. Right? So minus 270 times 200. So that is your total torque. Clear, class? Faham, Class?
Faham.
Class, are you listening or not?
Faham Doktor?
Faham, Alright. So that's my point tadi lah. Another one is about, I cakap about the torque kan. Okay, critical. Another thing is about torque. Torque at critical point tu. Maybe at groove, critical point. So if not given the KF for 2, you have to find the KF fatigue strength for torsion. TS stand for torsion. 1 plus no sensitivity for torsion. KT torsion. Remember, KT torsion you can find for torsion. You go, kalau shoulder, go for figure 4, chapter 4, shoulder. Kalau go for groove, remember, yang tadi is one KT for bending. For shoulder, go for bending case, first figure. Torsion is number 3rd, if I'm not mistaken. Second is axial. Okay? For torsion, you go to torsion. For torsion, what is the KT? Static stress. So what is the value based on ratio D over D, R over D. So you got your KT, then minus 1 QTS. Ini yang chapter 8. Chapter 8 is your notch sensitivity. Your notch radius intersect with the curve. Okay, we have 2 zone of that notch. I'm not showing you. Ulang jap. Okay, boleh nampak guys yang ni, notch figure 8.24. Hello class.
Nampak Doktor, nampak.
Itulah your notch radius. Be careful, notch radius yang zone, this zone, yang ini for use this for bending. This zone left bending and axial. For torsion use this scaling. And use this scaling. Your notch radius, so what is your shoulder notch or what is your groove, your notch radius in millimeters. So you go up and you intersect with the scaling of the, kalau torsion go for this right. Yang ni, this one is in KSI, SUT. So you look from the table what they gave you, AISI 1045 for example. You just take note what is the value SUT for megapascal, also KSI, and also your SY also, SY to find the certificate for Langer. Alright, so itulah yang I cakap tadi just now, torque, you got your, if it is given, do not waste your time to do this lah. So just take the value you given in the question. So your torque to torsional stress. Okay, torque, I always put the torque is mean. Kenapa torque is mean? Student always ask me question. When you have a shaft and you have bearing at O, then you have gear or pulley at here, right? So you have O, A, B, C, for example, O, A, B, C. You have torque between A and B. For example, you have gear like this. You have gear like this. This is your gear. It is turning like this. This one produce torque like this, and this one torque is like this. And you have a reaction like this. And gear like this. So between your A and B, we have torque. Between A and B, we have torque. So your shoulder or your groove is inside this zone AB, so we have torsional stress. If your groove to just outside, sometimes like for example in your example, right, your yang ini, remember your assignment on your first one, fatigue, no? Yang ini, yang this one, you punya ada certain, okay, macam ni we have torque between B and D lah. Macam ni we have gear, right? This one we have gear. Between B and D we have torque. Just before B tu, before B toward A we don't have torque. For example, like if you look the diagram, the location shoulder E ni. Kalau you somebody, siapa yang dah buat assignment tu, Actually, we don't have torque at E. Is this shoulder? Can you see the shoulder E ni? Is this shoulder E ni in within the torque zone or no? We have torsional stress at shoulder E. Shoulder critical, right? We have stress concentration factor, right? We have torque at E here. Plus.
No, doctor.
No, we don't have, because our pulley, our gear, this gear is mounting at B, and gear is mounting at D. Okay, the torque on the top, your torque diagram between only on B to D only. Before B, we don't have torque. The shoulder that you are, they don't have torsional stress here. Torsional stress only happen at the, so that your ni you kena cari B, C and E, right? B, C and E shoulder. You need to. Ni we have QA. QA actually there is no stress concentration like plane. You don't have your KF value. So in your KT is 1, your KF is 1. Okay. So yang ini C. C also just a plane diameter. It mean your KF is 1, not KF 0. So your stress that you calculate like bending just a pure lah. But your shoulder you have KF. Okay, you have KF. So KF shoulder R over D, D over D. So you got your KT, then you find your KF bending 1 plus Q bending in bracket KT bending minus 1. That is for bending, but we don't have torsional stress. Be careful, this shoulder we don't have torsional stress. But your example like this one, yang macam ni contoh yang tadi, apa yang tadi? Yang ni saya pun dah. For example, macam ni between B and A ni, kalau depend lah, kalau your shoulder tu, just be careful lah if your shoulder tu inside the torque zone, inside the torque zone tu, so you got to, we have torque lah, that's my point, we have torque. So why torque? Student always ask me why torque is always means, because while your shaft, okay, within AB we have torque, okay, because this is your zone. Actually the shaft is, we have OA, we have AB. Since the shoulder to inside, let's say shoulder to inside your torque, so along when the shaft is rotating, the direction of your torque is like this, right? Okay, the direction of your torque is torsional stress. Your torsional stress is like that, because the shaft is rotating. So this is your element. So your torsional stress like this, torsional stress. Okay, the left hand is going upward lah. So it remain the same. The torsional stress is constant. Okay, while the shaft is through time is constant below. That's why your torsional stress with time it remain constant. So, kalau it remain constant, you mean your torque amplitude is 0. We don't have. Kalau you ada sine wave, we have amplitude, but it's constant line amplitude. We don't have alternate or amplitude 0, but we only have mean. Yes, we have mean. Mean mesti ada. Faham guys? Clear or not? Plus.
Oh, betul.
So tau mean Jadi tau, that's why I cakap tau mean. Kalau for shaft, this only for shaft case rotating. Kalau your bending tu always alternate, they don't have mean. Bending, remember, bending we don't have mean is 0. But if you have, because it complete reverse, we have alternate only. Complete reverse, because up is tension, bottom is compression, but the same magnitude. So complete reverse. So the mean is 0. Okay, completely reverse. For bending, normally for shaft is completely reverse, unless there is a third special case. Normally when shaft rotating, the alpha for bending is completely reverse. So the mean is 0. Okay, we have positive and negative in the same value. So it means complete reverse. So we have sigma alternate. That's why yang sigma is now sigma alternate. This one, sigma alternate. And tau just now, tau mean. So you have to KF torsion. If it is given, don't waste your time. Use that value. 16 torque over pi d cube. So what is the torque? Torque is from your torque diagram. So what is the value from your torque diagram? Yang as I told itu je lah. Yang the two both of tension of the cable plus time the radius minus yang the other yang loose side time the radius, your total torque. So they will be, if given, use that value. So this will be total in megapascal. So okay. After that, what we do? We need to find the safety factor SN, endurance limit. So what is SN? Endurance limit. Because why? we need to find the safety factor, right? Kan? Safety factor. So safety factor tu, okay. Before we find safety factor, we need to find the combine kan? Equivalent load in DET, right? In DET equivalent load. So we need to find the combine because we have sigma alternate and we have tau mean. So we cannot. We have to use based on the equation sigma equivalent alternate. Apa equation sigma equivalent alternate? Square root apa? Kelas. Plus 3 tau alternate square. Class, are you watching or not?
Yes.
What is sigma equivalent mean? Sigma mean over 2 plus
Tau M square plus
tau m
Sigma
square
mean.
plus sigma mean
over 2 square.
over 2 square. Kalau you tak sure, you tengok this one. That's why I will give you the figure extract. Semua ada figure-figure tu yang yesterday I share you already. Kalau you tak sure, you tengok this one. The equation is there below after your table 1.
Maybe page 25.
Page
25.
ni. This one. Class. Okay. Class. Are you watching the textbook or not? Ni.
Yes.
This one Okay, for our case just now, for shaft, okay, sigma EA apa, do we have tau A tak? Do we have tau A? For our case? No, zero, right?
Betul.
So, sigma EA equal to sigma A lah. Okay. Sigma EM, do we have sigma min? Do you have sigma min?
Yes, Doktor.
Huh?
Yes, Doktor. Tapi negatif kan? Because of compression.
Apa sigma min bending ni? Do you have sigma min?
No.
Bending, zero for bending, zero.
For bending, ingat ada axial load tu.
We don't tak. This case yang if there is no normal case, no axial. If be careful, sometimes the question, they have axial load. Axial load they have. If the axial load, it depends. If sometimes the axial load, even the axial load along the shaft. If the axial load, okay, this is sigma axial along the shaft. Sigma axial load along the shaft. For example, you have a shaft, and we have axial load. Remember, we already discussed one example, right, in class. Axial load, axial stress. We axial load, you mean we have axial stress. So sigma axial constant. So sigma axial also, we only have sigma mean. Sigma A is 0. We don't have alternate.
Just need some clarify if the axial load is compression, then our sigma E could be negative kan?
Sigma E, because the equation sigma E, kalau because this is square, everything will be positive.
But
Oh,
then
I can
sigma
understand
M
you
square
because
kan?
this one. No, tak, everything will be magnitude sigma EM, sigma, okay, I understand. If we will be in compression, let's say sigma mean, mean axial load, we have sigma mean, okay? If we have axial load, if we don't have, okay, go for our case just now. Okay, itu later on. For our case just now, apa tadi? Kita have, we don't have sigma mean, right? 0, right? 0. Class. Faham I mean, we don't have axial, just a normal case. So we only have tau mean only. So we have, so your sigma EM, put your tau mean. Tu holan yang tu holan, yang combine tu holan. Okay? Kelas, clear or not?
Yes.
This sigma A ni yang you have already multiplied with your KF, is not just 32 moment. Mesti because we have stress constant. Because I'm talking about shoulder or groove. Tau mean yang already multiply with your AM value. With your KF torsion. Tau mean. Okay, so then we know that the safety factor, we have our sigma EA and sigma equivalent means. Okay, equation for safety factor for Goodman, sigma, apa dia macam mana? Sigma EA over S
UT.
SN. We careful. SUT saya pun dah perlu ke SN kan, kelas.
Oh, I sense.
Kelas, be careful. Sigma EM over SUT. Because 1 over your certificate factor, Goodman G, NG, Goodman certificate. So we need to find the certificate factor, either it's safe or not. So we need to find the SN. SUT you can get from the table, right? From the table property at the back. Since we already know our sigma EA and our sigma EM, so the next thing to find the endurance limit. So what's the endurance limit? Endurance limit is CL, CG, CS, CT, CR, SN prime. Ini straightforward lah. Ini actually this one you can calculate earlier pun boleh. 0.5 to your SUT. Okay, CL, I hope you know lah how to get your CL. Class.
Oh.
Are you watching or not? CL, load factor, bending 1. Okay, load factor kalau bending. Be careful, kalau the soalan, which one yang much bigger? Is it torsion or bending? Tapi normally for shaft, normally it's bending. Tapi sometimes you have to check. Sometimes even the torsional, let's say for example, your pulley radius is very big and it produce a big torsion, the force that acting on the belt of the pulley is very high, like heavy duty crunching machine. Either the gear tangential force is very big, and also maybe the tension belt of the pulley is so big. It means the torsional stress is actually much bigger compared to the bending acting on the shaft. Sometimes it happens, if your torsional stress, it means that the torsional stress that you calculate here, you remember your tau M, the megapascal is even bigger than your sigma. It means torsional stress govern. So you cannot use bending, you go for torsion value. Clear tak kelas? Sini. Just to remind you, kelas. Tapi normally case, when you find that your sigma A in megapascal is much bigger, normally the case is much bigger than your torsion. So we straight away use bending. Okay? Clear kelas? So CL is 1. So you know your CL, you got what is your CG. Okay, CG, if it is shaft, look on your range of the diameter of your shaft. Let's say for example, your shaft diameter is 30 millimeter. Where is 30 millimeter? Between 10 to 40, so 0.9. Not the big diameter, guys. Class. We have bigger diameter, right? For example, shoulder, we have small diameter. Use small diameter, not the big diameter, not capital D, small D, the diameter of your small diameter. Okay? Smaller diameter, the D. If D tu what range, so that will be your CG. Your CS, surface factor. Surface factor, where is surface factor? Inilah. Normally shaft is, you read the question. Sometimes, previous year punya question, the shaft is polished. Be careful. The shaft is grind. The shaft is raw. Kalau polish, you use straight line je lah. Kalau ground, you use the second line. Tapi normally the shaft is machine. Read the question. Normally shaft is machine. Machine, I hope you know, based on your SU, in gigapascal or your ni, you can get your material SUT. Intersect with the line of your machine. Normally machine. No machine is to read your question. It's stated machine. So you got your CS. So you got your CS value. So you got your CS value, CG value, CT. Temperature, be careful. If given, convert your temperature into Fahrenheit. Use your Google. Celsius to Fahrenheit. Okay. So if less than 140, so it's 1. Okay. CR, be careful. Sometimes if it is not given, 50% reliability is 1. But it is given. If nanti read the question, do not jangan cuai. Okay. 90% 0. Kalau 95, kalau 99% 0.814. Be careful about that. Be careful about that. You punya reliability. So you got your CR, so you got your SN value lah in, and also your SUT, so you got your SN value in megapascal. So then only you can find your safety factor lah. From here you can get your safety factor based on Goodman. Okay. Another thing, okay, also Langer. Langer equation apa? Langer equation macam mana? Plus equation for Langer macam mana? Sigma EA over SY plus sigma E M over. So, okay, are you watching or not?
Yes, betul.
flanger. Ni also check. Kalau question ask you to ni, kalau tidak you lose another half point. Ni also kena check. Either is safe.
Oof, fuck me.
Alright, Clyde. Okay. That's all for fatigue. I want to go for
Kadang-kadang
gear.
kita rasa
Ada
nak
question tentang fatigue?
Menghilang.
Oh, yang tadi
Tapi
just now.
hakikatnya sebenarnya
Kalau
kita
combine,
nak rasa
kalau
dia
combine
cepat
ni, okay, just now, tadi yang you mention, okay, that is a case where it is combined.
Ha?
Other case where in shaft tu you have, for example, you have two pulley here, and also the shaft. Remember, we already discussed. We have axial force. So we have sigma axial. Kalau you have shoulder, it means long. If your shoulder groove, of course they have axial because axial is along the shaft. Okay. Tapi depend. Kalau the question is like this, remember you punya this one, you punya previous assignment on your fatigue. That's a case. Ada part where they want you for this diagram, for example, they want you to draw the shear diagram, moment diagram at both plane, and kemudian you have to draw the axial. I think I already share you the diagram of axial force kan? Axial force punya diagram. So any at shoulder E tu we have axial or not? Ada argument on that. Because what axial happen where okay, they is designed this bearing A support axial. So okay, we have axial at this B here, Fx 1.37, then up until B we have another Fx is 0.26. Okay, you can find this one, you can find Fx. But axial force diagram from DC up until B, the value of axial force is only 1.37. But until it reach at point B, you have to add this Fx. So we have, I think, about 1.42 if I'm not mistaken, Fx. We have total, then total this one plus this one, you have 1.42 axial force. So just to B to A, the axial force is much bigger. Understand tak, class? Do you understand what I'm talking about? Hello, class? Class, boleh dengar saya ke?
Dr. Please again?
Your previous assignment, axial force, you have to draw the axial force, right? Axial diagram, right? Okay, at DCB, the axial force is 1.37, but until it reach B, we have to add this Fx from the axial force of this gear. Can you see the gear have another additional axial force where Fx in it already, you find it already. Hello, can you hear me or not?
Yes, Tada.
Yes.
Okay, axial force to the left of B, from B to A is much greater from before B. Understand that? I think I already share you the diagram for axial force, right? Okay, it means that after B to A, the axial force is much greater. It means 1.37 plus the component of this force. I think it's 1.42 total force at B. You add these two. So, okay, at shoulder E here, okay, this kind of example. What is the axial force? Is it just 1.37 or this one 1.37 plus this Fx? Do you understand what I'm asking you, class?
Since we want to find the critical, so I will use 2.4193 lah. The plus on. 1.37 plus.
This is 1.2, right? 1.42 man. 1.42 kilonewton, right? Plus 1.37, right?
Yeah, since we want critical, right? So I will plus it lah.
Yeah, you plus, yeah. Yes, you will plus it. And this one is 2. Berapa? Total is berapa? 2.42 plus this one.
2.4193.
Tak might, okay. At shoulder, that's the value. That's the value in this guy. Sometimes the question is, if, like for example, remember that we discussed, it means along. Sometimes the question along the shaft, everything axial is the same. Okay, kalau you have axial force, my point, axial force, you have to go for KF axial, kena cari lah. 1 plus Q for axial, same for bending. Q axial, KT axial, minus 1. Ini I hope you know lah. KF axial, this one KF for axial. So your axial force for sure is what? Always axial force take the smaller diameter, not the big diameter. D, small d, not big D, is 4F over pi d square. This is only for solid shaft in the equation. So you have to times with your KF axial. Sometimes KSA is given, you don't have to calculate this. You just use the KF axial, like in your previous assignment. So there will be your sigma axial ni, because I cakap axial ni along the shaft is remain the same. Sigma axial with time is a constant line, remain the same. Even the shaft rotating, but axial stress is remain the same. Unless bending completely reverse because up tension, bottom compression, tension compression. Same goes for torsion, remain the same, constant line. Axial remain the same. This is normal case like this, remain the same, remain the same. So axial we only have sigma mean. Sigma A is 0. So okay, to answer your question, kalau remember you punya total equivalent force sigma EA equal to square root sigma axial square plus 3 tau. So sorry, sigma A sigma alternate square plus 3 tau alternate square. Normally alternate torsion we don't have 0, but be careful about this axial. Be careful about this one. Ini we have sigma bending plus sigma axial. Clear guys? Sigma axial plus for this one. Clear or not?
Sorry, Toto, can you repeat again?
If we have our case, we have like this case, we have pulley and we pass additional. So our sigma EA equivalent stress based on DET. Remember the equation is right. Sigma EA is sigma alternate square plus 3 tau alternate square. Sorry guys, my mistake. Sorry, saya pun no. Okay, do we have salah guys. Sorry, saya ni bahaya ni salah. Sigma alternate.
Confused me.
Yeah, sorry, my mistake. Sorry, my mistake. Sigma alternate, what do we have sigma alternate? Sigma bending, right?
Yeah, sigma bending.
Yeah, sigma bending square plus, okay, that's all lah. Sigma bending. Sorry guys, my mistake. Okay, yang sigma AM, sorry, be careful. Sigma M over 2 plus, apa tu?
Tau M square plus tau sigma M square, sigma M over 2 square.
Sigma M over 2. Where, right? Okay, yang sigma min, sorry guys, my mistake. Sigma min apa? What do we have sigma min? Sigma min ada apa? Axial lah kan? Ya. Sigma min we have axial stress lah. Axial stress time your KF axial, okay? So this one axial lah. Betul tak? Your axial. Bending we don't have mean, right? Bending complete reverse we don't have mean. Mean is 0 because bending completely reverse your mean is 0. Plus, okay, yang ni torsional stress we have, yes. Torsional stress we have lah. Torsional stress your top, yes. This one your sigma axial over 2 square. Betul tak kelas? Kalau that's the case.
Toto, if we don't have tau mean and then we have sigma mean, but is the compression is it equal to 0?
Janganlah tanya. Awak buat benda yang sama.
Because in negative lah, if we substitute negative then become a negative sigma M over 2 plus.
Dia kalau kumpul besar.
Yeah, good question. Okay, if
Dia
that's the case, you punya since this one is negative, so this one will be negative. You square it, it become positive, right? Become positive.
Itu touch phone. Mami budak lagi motor
You can good question. So this one negative minus this one it become 0. Sigma in that case. Saya tak boleh recall. Tapi normally rarely we have that kind of case lah. Be careful but nanti
ni dia kalau macam ni dia tak ada tau M, so saya dapat negative axial load kan, so saya
understand. Yeah, understand.
So menjadi 0 pula.
Yeah, understand. Ini compression this one become negative, right? If we have axial, if it in compression mode, and this one negative value, we square it. Nanti I check for you nanti. You look, sometimes they will be highlight dekat in your the other mention. Please read. Sometimes jangan depend kat saya guys. Not fair jugalah. You kena okay. Tapi normally the case tak ada rarely we have that kind. Tapi I understand. You mean in compression mode, compression mode your sigma. So this one negative, so this one positive. Yeah, of course it become 0, right? It become 0. If that the case, I boleh cakap you. Generally, my question kalau 0 it become 0 lah. Sigma E min. Sigma E min because this is a question lah. Because yang ini is not magnitude, it just value. But this one we square it becomes magnitude, right? Kalau 0 is sigma EM is 0. Tapi be careful, I got to check again. Then. Tapi your exam will not this kind of question. or not this question. They did ada mention sini kalau maybe something that I miss. I cannot recall lah. Maybe if you are in compression, of course it will be in zero, your sigma EM. Or do we take this one also value negative? We take this one, we assume positive become positive. Because sigma EM, because when our graph ni, kita plot the sigma 1, sigma 2, this is your sigma amplitude. This is your sigma mean. Sigma mean we have positive and negative. Okay. Sigma amplitude is always positive side. Sigma amplitude always positive. We go your SN here, this one your SUT. This is your basic line. We have another one is SY is much bigger than your endurance limit and your SY. But actually Goodman punya zone ni kita within this zone. Okay, my point is if you plot sigma AN ni, your sigma amplitude always positive, but your sigma M tu can be not always positive. To answer your question, it could be zero lah. Okay, sigma EM ni could go for positive and could go for negative. Because the value is not, because amplitude always positive. Sigma EA ni always go for positive value. EM ni can go for negative. If that the case, kalau compression negative, it could be zero lah. Sigma EM zero. To answer your question. Clear?
Clear, Doctor.
Alright. Okay. Okay, then you find your safety factor, your Goodman and your Langer lah. Okay. Next one is about, okay, boleh I go for gears? Gears. Plus. Right? Okay. Now for gears, Gears. Okay, let's go back to our e-learning. What is our gears? Here sample problem. Look at this sample problem. Okay, can you boleh nampak ni case sample problem question 1, question 2, boleh nampak guys?
Yes, Doctor.
Nampak alright. Okay, I want you to focus on this question 2 let's look at this question 2. Okay, the figure below nampak ni? Class.
Yes, Doctor.
Okay, the figure below show a dual output power transmission. Okay, if you look this one, figure below ni, you have a shaft. Okay, the input. Okay, sometimes the question will be like this. We have inputs from motor. Nampak tak? We have gear 2 and gear 2. Gear always starting at number 2. 2, 3, 4, 5. Okay, so it means the center shaft ni is a driving. Center shaft is driving. So it will drive 2. Okay, sometimes question. Kalau this kind of question, kalau I'm afraid kalau you guys tak boleh answer, be careful. Nampak input power for motor, okay, on the shaft, the middle shaft, okay, let's consider this shaft 1. Okay, this shaft 2, shaft 3. Okay, middle one is shaft 1. Shaft 1 actually is a driver. You have to drive 2 machine, one on the left, another second machine on your right. Nampak tak? Okay, input from the motor. It means middle shaft ni is connected to motor. Okay, so it will be driving. Okay, attached gear N2 ni, 18 teeth, 18 teeth, will drive the shaft on your left, which is your shaft 2. So, it means your main shaft at the middle drive 2 system. So, he said 60% of the power delivered to shaft 3. Okay, 60% of the power from this middle shaft, okay, you calculate motor is what kilowatt, right? Okay, let's say for example 100 kilowatt. Your middle shaft power is 100 kilowatt. 60%, 60 kilowatt go transfer to this output shaft 3. 40 kilowatt to shaft 2 on your left. Clear Maksud dia macam tu. Alright? So, this kind of question 60%. Okay, now, okay, draw the free body diagram or calculate all the forces. Okay, ini yang kita tak discuss lagi. Alright, okay, so how do we solve? Draw the free body of the gear and calculate all forces torque with the speed of both output shaft have been reduced by 3. So it means the output shaft reduced by 3. Shaft, okay, so reduced by 3. Okay, input is 100 RPM. Okay, input is one. Okay, show transmission 13 horsepower motor 1000 RPM in clockwise direction. You mean looking from the left, it go for clockwise direction like this lah. Okay, input clockwise direction and 1000 RPM. Okay, 1000 RPM. The speed and the power is 10 horsepower. Okay, 13 horsepower. The power per motor is 13 horsepower. Okay, lepas tu draw the free wheel of the gear. Okay, another thing, before this thing, I want to share you another example yang before that one. Okay, yang ni, before that. Look on this one. Okay, okay, this one I'm not asking you only. The second part, assume gear 3, gear 5, you have system ni. This kind of system. Class, I skip this one first. Yang ini dulu. Class, yang ni boleh tak? Are you watching or not? The second part. Assume gear 3 ni, and gear 5 is 70. Gear 3 is, and gear 5 have 72 ni 90. So ini both 18 and 10. Okay, ini right. Ini the input shaft is from yang ni. On gear 2 ni you punya input shaft. Okay, calculate the RPM of the output shaft. So how do you calculate this thing? Plus, we have yang ni. We have this small gear. Okay. And we have this bigger gear. Okay, this is a shaft in the middle. And at the back we have gear 4. Okay. Gear 4. This is gear 2 and 2. This is N4. Gear 2 and ni is 18. N4 also 18. This and gear 3 is 72. Gear 3 is 72 and gear ni it drive another shaft number 3. This gear. Okay. Okay, this is the shaft. This is and 5 is 90. Boleh nampak saya punya video saya nampak kelas? Hello kelas? Kelas?
Yes, Doctor.
Boleh nampak clear Okay. Okay, the first thing, what is the speed? Okay, calculate the RPM of the output. Okay, this is input shaft. So this one will be input. Okay, input shaft and okay, this is input shaft. The direction dia tak bagi. Okay, dia punya RPM. Okay, the motor. Okay, the seperti the motor is clockwise. So it mean clockwise. This direction clockwise. Okay, this direction clockwise and is 1000 RPM. 1000 RPM and motor is 8 kilowatt. Power is 8 kilowatt. Okay, power is 8 kilowatt. Okay, the first thing question is calculate the RPM of the output shaft. Okay, calculate RPM. Okay, we know that N last E N. Can you boleh nampak saya punya live ni ada yang tak nampak? Portion tak nampak ke? Boleh nampak semua
Boleh, Doctor.
E N L E N L. Saya punya E is ready. Gear train is drive. Drive over driven. Faham Saya terbalik. If you note ini. E is drive over driven. So what is driving? In this case, what is driving? Okay, this one they rotate like this. Ini will rotate like this lah. This one counterclockwise. It also counterclockwise. And this one go clockwise. So what is your punya animal? Calculate the RPM output shaft. So this will be output shaft. Okay, output shaft. What is the speed there? E equal to what is driving? Driving apa? Product to number
N2 N4
N4 driven N3
N5
N3 and N5. So we have N2 is 18, N4 is 18 over N3 is 72 and 90. So what do we have? It is so and last apa? And last is itu 18 kali 18 over 72 90 and first berapa? 1000 kan 1000 RPM. Berapa jawapan Berapa kelas? 50. 50 RPM, 50 RPM, okay? Alright, this one is 50 RPM. Okay. Alright, dia punya second part, draw and calculate all resultant force on all gear. Ini saya nak cakap dengan you. Okay, tengok sini. Okay, kita go for gear 2. Tengok sini, gear 2 Okay, gear 2. Tengok, gear 2 clockwise Gear 2 clockwise. Gear 2. So we looking from the left Gear 2. So it's clockwise, it's rotating like this. And apa tu, reaction, this gear 2 reaction apa? F tangent, okay, see, because kita punya gear 3 is on your right of your gear 2. So this will be your gear 2. Okay, the force F tangent for ni downward ke upward? Gear 2 is driving. Yeah, upward. Jangan confuse ni. Upward. Because gear 2 is driving. The teeth of gear 2 is touching. Okay. So F tangent 3 to 2. So F radius always focus to the center. F radius 3 to. Okay. Now we need. Okay. This is shaft. Consider shaft A lah. The first shaft A. So we have. Okay. Since we have FT is upward, we have AY lah. Downward. Since F radius to your left, to the center, we have AX to your right. Also, we have, remember, we have F tangent causing counterclockwise torque. So we have torque at A. You can call moment lah. It's actually to call it moment, but I call it torque. Torque also problem. Torque A. We have to consider. So this will be our free diagram. So this is not idler. Idler we don't have torque. Okay. So how do we get the, first we need to find, okay, we have this thing, kalau we need to find the, okay, calculate, draw and calculate horizontal force. Draw and calculate means you have to find what the value. So this will be the free body diagram. So we need to find the F tangent. So the power is what? Power is F tangent times velocity. Betul tak? Plus. Plus, saya ingat tak? Power if it is in kilowatt. So ni kita revision guys, you kena tahu ni semua. Power is what? Look on your notes. PowerPoint. Ulang je. You can see my PowerPoint notes. Nampak kelas? Gear. Kelas. Hello kelas. Kelas okay. Power is FT. Okay. This is yang FT time V. Ini is for English. For metric, power FT time V. Betul tak kan? Okay. Your velocity pi dn over 12. No, this one English and bottom one. V is pi dn over 60,000. This one for metric. Okay, for metric, to answer that question just now, mana tadi? Yang ini. Okay. Draw, okay. If you look on my live video balik, FT, ni FT32 lah guys. Pasal kita start from the pinion, the gear tu, FT32. We need to find FT. Since power is given, power is 8 kilowatt. So it's 8 kilowatt. So it means 8,000 watt lah. 8,000 equal to F tangent 32 times velocity. Okay, velocity. Okay, we need to find what is FT. Once you know FT, you can calculate everything lah. You punya F radius and transfer to all the other gears. So you need to have to start from the pinion gear 2. Okay, what's your V? Okay, we need to find FT, but we need to go know what is V, right? V is, okay, if you look on the notes, V is, for metric, V is pi dn, V is pi d, because this is gear 2 kan, pi diameter 2 times n2, n2 is speed of your gear 2, V is already given 1000 RPM in RPM over 60,000. So we can get our V. But we can get our V since this one is already given 1000 RPM. Okay, diameter of the gear. Can we get the diameter of the gear? What is the diameter of the gear? Plus gear 2. So to get V, we must know diameter. So diameter, we know module is diameter over N, right? Yeah. Module is diameter 2 over N2. Also diameter 3 over N3 and so on. Module is the same. So it's given that your module, mana tadi your module is given is 4 kan? Module is 4. Okay? 4 mm. Module is 4 mm. 4 mm. Actually 4 mm unit. Okay, so your diameter 2 is module times your N2. So your 4 times your number of teeth of gear 2 is 18. 18 kali 4 berapa? So you punya ni berapa? 18 kali 4. So we have diameter 2 is 72 mm. Class, are you watching or not? So you can get your V. V is pi kali 72 mm. So your diameter ni is in millimeter ya. This one diameter is in millimeter. Okay. Times 72 times your N2 is already given 1000 RPM over 60,000. Berapa tu?
Fucking go.
Berapa?
Kalau dia keluar bagi tahu dia call tu Boleh.
Are you watching or not, class? Class, are you there?
Yes.
Hello, class.
Yes,
Can you hear me?
Yes.
Dengar tak? Dengar. Saya
Dengar.
takut line putus ke penat saya bercakap.
Jangan betul. Bukan nak dengar Muslim.
Okay, so we have B is 3.77 meter per second. That will be our V. Okay. So once we know our V, then we can get our apa? Bila kita tahu V, then we can get our FT lah. So 8,000 FT 32 equal to 8,000 watt. So that's 1 kilowatt over 3.77 kan? So ni
Hikayat tu dia.
meter
Sorry.
per second. So 8,000
Tim
over
Raya Suria. Tim Raya Suria.
Okey, mari Suria. Itu ada.
bagi 3.77. So we got
Banyak bangla.
FT 32 is 2122. Okay? 2122.02. 2122 meter lah, I make it rough. Kalau guys you take decimal 2 decimal point, so much accurate.
Maghrib tu.
Just checking just checking solution here. Actually solution already, you can check the solution.
Adik-adik bini adik-beradik.
Macam mana
Terus tu dia 2122 kilometer. Alright, class, are you watching Okay, since you get, if you look my live video so what is the fee? Fee is given that apa fee dia?
Jangan laju sangat.
Our fee is 20 degree already given, right? So F radius 32 is
Got reject.
2122 tangent fee. So we got apa value dia? Tangent 20 times tangent 20 times your (772.35 Newton). Okay, that will be your F. Okay, 772 Newton. This one is in Newton. Right, so that will be your value. So ini adalah, so you punya ni, so AX equal to, okay, so you punya free body diagram of your gear A tu, that is gear A. So we have this one is gear 2. Gear 2. This one is AY. This is AX. So we have our F tangent at least. So yang ini F tangent 32 is 2122 Newton.
Dan ni
Ini
sini
F
aku cek.
radius 32 is 772.35 Newton. So AY is the same value lah. 2122. Ini AX is 772.35. So okay, remember ini produce counterclockwise, so we have clockwise torque A. Torque A is, are you with me guys? FT32 times ni diameter gear, diameter 2, okay? Times diameter 2 times 2 torque plus, faham torque A ni plus
brother.
torque A ni, summation torque ni, torque A you can use torque A FT tangent ni times ni lah. Pasal torque A ni go for the F tangent ni cause counterclockwise turning direction, but the reaction is go for clockwise lah at the center of your gear from the shaft. So FT32 times diameter 2. So you got 2122 times diameter just now of the shaft. Its diameter is 72. 72 is 36 right? 36. Okay. 36. Okay, 76. 392 Newton millimeter. Okay, 392 Newton millimeter. Hold on. Hold on. Bukan apa? Salah ni. Kenapa dia top ini is 7.8 772. Oh pula 772 ni. Solution ni is wrong Hold on je. F tangent 2122. Oh. Mana boleh? Guys, are you watching the solution or not? Ni. Plus. Hello plus.
Ada.
Am I sharing you the solution? Are you watching the solution?
Yes, betul.
I'm sharing right. Ni wrong kan? This cannot be ni kan? Not 72 kan? This wrong ni. This one is wrong ni. Ini F tangent, top. F tangent not 772 kan? It cannot be 772. Top ni F tangent. What is F tangent? This F radius. It take the radius. No, not 772. 2122 kan? Tu guys Ini wrong ni
Betul.
salah tu. Dia ambil F radius top Okay, if you look my live video, so that's your top value. Okay, if you go back to the question again just now, ini nanti some of you nanti at the back there we have gear 4. Okay, what is your gear 3? No problem. Gear 3 macam mana kan? Gear 3 terbalik, just a reverse lah. So this will be your gear 3. Okay, gear 3 tengok sini. Gear 3 is to your right of your gear 2, right? So gear 3 is like this. So your F radius, F tangent is upward. So your gear 3 is downward. This is F tangent 23. Sama dengan value of ni F tangent 23 equal to F tangent 32 equal to 2122. So yang ni is 2122 Newton. Guys, bila you buat exam, you cantik-cantik tulis, jangan cincai. Saya susah nak marking. Ni F radius like this. F radius 23 equal to F radius 32 equal to 772.35 Newton. Ni 772.35 Newton. This is F radius 2 to 3. Okay, this is not ideal guys. If you look at the question, because it's shared on the same shaft. Understand tak? Okay, this is not ideal gear because it's not in the middle Okay, so gear 3, okay, gear 3 we have, okay, this is sharp B. We consider this sharp B. So this is since FT is your BY is upward. This one F23, your BX is this one. So you can got your, actually yang tadi yang ni pun you kena tulis guys yang tadi for your gear 2, your AX equal to, tulis ni, gear AX equal to 772.35 Newton, AY equal to 2122 Newton. Make it direction, AX direction, the one positive, make it direction. AY downward positive, make it direction. Always bulk your answer. Okay? Always bulk your answer. Okay? Bulk your answer. AX. Okay, yang ini BY. Yang ni for this case, what is okay? We have F tangent downward produce counterclockwise. Okay, produce counterclockwise. This one produce counterclockwise. So this one your okay. This one on your left they produce this one. The top F tangent time the D is your diameter of your gear 3. The times the radius of your gear 3 it produce counterclockwise direction, but your torque reaction will be reverse lah, so it will be torque B should be clockwise. Clear? Clear? Since F tangent ni time the radius produce counterclockwise, and your reaction must be counter react. The torque direction, or you can call it moment also, or you can call it torque also. It goes for clockwise. So BX from here, BX, FX0 we have BX. This direction is 772.35 Newton. This direction. Okay, this will be your answer for BY equal to 2122 Newton upward. Okay, it will be BY. So what is your top B? Be careful. Top B is not the same as your top A because the radius of B is big. Gear 3 is bigger. So top B, right? Are you watching? Class, what's your value of top B? Top B is berapa? F tangent times the diameter. Your F tangent 2 to 3 times the diameter of your gear 3 divided by 2 times the radius. So diameter 3, what's your diameter 3? Diameter 3 berapa guys? Modul tadi just now is what? Modul is 4 plus. Diameter 3 is module times number of teeth of your gear 3, okay, equal to 4, module is 4 mm times N3 is 72, right? Okay, N3 is 72. So diameter 3 is 72 times 4 is 288 millimeter. Class, are you watching or not? Class.
Yes, okay.
No, alright, okay. I just need to confirm. Okay, top B, FT23 ni adalah 2122 times 288 times radius. Top times radius. This one is diameter times radius. So you got the value is 38 divided by 2 times 2122. So your top at B is 30.5568 Newton millimeter. Let's look on the D. I think solution yang ini dia gear 2, gear 3 torque is betul. Ni dia Newton meter, mine in Newton millimeter. 305,568 Newton millimeter. Alright. Okay, that will be your gear 3 free body diagram. Okay, that's all for gear 3. We already have BY, also the same direction. Okay. Now, my question is, what is the value of, macam mana, how we going to find, guys, are you watching it? What about this gear 4? Ini yang saya discuss with you, right? Okay, what about gear 4? If you look at the pad there, nampak tak? This is your gear 3, guys. Ini you punya gear 3. Gear 3. At the back there, we have gear 4. Where gear 4 is, and 4 is 18, and 3 is 72. We already have our gear 3 punya free body diagram. So ini at gear 3, we have, nampak tak? If you look my drawing ni, we have force ni, we have force F tangent. at gear 3, this is your gear 3, right? And 3 is 72. We have F tangent 2 to 3, where the value is 21 to 2 Newton. And we have
Pasal dia bagi apa?
radius this direction.
Ada yang kita kena hantaran hantaran.
We have F radius this direction. F radius 2, 3, where the value is 772.35 Newton. Kan? Okay, ini you punya diameter 3. Okay, ni we have N4. We have this diameter 4. You punya tadi turning dia macam ni you punya question tadi dia punya turning of you punya this one is clockwise, this one the turning is this one go for counterclockwise, this one also go for counterclockwise, the turning of you punya shaft counterclockwise. So at our gear 4 ni, if you look on your free body, pasal we already have free body of gear 2 and gear 3, what about gear 4? Gear 4, okay, if you look for gear 4 punya, gear 4 is like this, right? Free body diagram of your gear 4. But if you look on your gear 4 is driving your gear 5. And the shaft of this middle, the shaft in the middle is driving. Nampak tak? Is driving the gear 5 where it is 90 this. Okay. Is the turning of your shaft of your middle gear where you have gear 3 and gear 4 is turning counterclockwise. So at gear 4, okay, this gear 4, so you have reaction from gear 5 at this quadrant. Betul tak? Class, are you watching or not? At gear 4,
Betul.
so the reaction from gear 5 to gear 4, is it F tangent from F tangent 5 to 4? Because we need to do the free body diagram and the value, the magnitude of the force kan, of this gear 4. The F tangent from 5 to 4, is it downward or upward?
Downward, Doctor.
Yeah, you're right. Downward. So it's a bit downward because he is driving. Gear 4 is driving gear 5. Gear 5. So this one F tangent 5 to 4. Tapi the problem, what is the value of tangent 5 to 4? How are we going to find the value of this F tangent? If we know F tangent, we know F radius, no problem. Apa value F tangent 5 to 4? But we know the F tangent to 3 here is to 1 to 2 downward. Is it the same? Is F tangent to 3?
I think we need to calculate again by using the formula.
What formula?
The FTV, that one.
Okay, kalau ikut this is your shaft. What is equal to 0? Summation of what equal to 0? Summation of torque, right? Along this shaft. Betul tak? This shaft. We have shaft here. F tangent times the radius of here, when just now we have at gear 3 and the torque is 305,568 Newton millimeter. That 305,568 Newton millimeter, is it the same that of this F tangent 54 times the radius of gear 4? Is it the same? Same, right? Summation of torque must be 0, betul tak guys? Plus.
Oh, dia macam yang chapter 2 punya lah.
Yes. Yeah. This F tangent already got it to 1 to 2 times the radius of this gear kan. This radius of gear kan just now kan we already got it. The diameter of that gear is 28 times the torque of this 2122 times the radius, we got 305,568 Newton millimeter. Yes, this one produce because shaft we need to balance the shaft, the torque going for this counterclockwise, but it must be apa? Nampak tak F tangent here is downward. Nampak tak F tangent 5 to 4 downward. It go for this one go for positive X, and this one go for sorry, this one go for okay, this one go for this direction, right? This one go for direction, this one go for the top ni go for this direction. We go for negative X. Cancel out. It means this F tangent 54 times the radius of this gear 4. This is diameter 4, diameter 4. Times the radius of this gear 4 equals to the top produced as gear 3, 305,568. Clear, class? That's how you solve it.
Clear, Doctor.
Take note. Nanti exam this kind of question you tak boleh jawab. Ni I already we discuss ini. 568. So this one must be equal. So the top must be equal. So F tangent summation, or you can wear it like this. Summation top long X equal to 0. So you mean F tangent 23 times the diameter 3 over 2 This one you go for positive X and this ni negative. This sorry positive minus pasal this F tangent ni go for apa? They go for like this. They produce torque like this. They produce for yang ni go for like this. And this one produce the torque like this. They produce the torque. No, this one produce torque yang what we call it is apa? Counterclockwise. Yang this one go for counterclockwise. Counterclockwise it go for like this. Sorry guys, ini terbalik. Ini negatif, sorry. So actually tak you buat like this negative plus this one F tangent. Ini F tangent 54. Ini diameter 4 gear times diameter gear 4 over 2 must equal to 0. But we know already this one. The value of torque ni is 305 kan. Jadi maksud dia F tangent ni F tangent 54. F tangent 54 times diameter gear 4 over 2 equal to 305,568. Okay, what is the diameter of gear 4? Diameter of gear 4 berapa? Diameter ni radius torque ni radius, diameter over 2. Diameter 4 is module times number of teeth 4. Number of teeth 4 also 18. 4 times 18 equal to apa tadi? 4 kali 18 is 72, right? 72 millimeter. So F tangent 54 times 72 over 2 equal to 305,568. So F tangent 54 ni equal to berapa Newton? Apa? 8488 Newton. Clear tak? Clear faham apa saya cakap?
Faham doktor.
Gear 4 tu betul 8.488. Okay, so it means once you got your gear 4, so summation, my point, summation of torque equal to 0. That's the point. Summation of torque is 0. Kalau you cannot buat, you can check how to get the F tangent. Summation of torque is 0. You already know this torque 305,568. So F tangent time the radius of this gear must equal to the torque at 305,568. So once we know, then so our figure diagram of gear 4 is like this lah. Okay, gear 4, I draw it again. So this is your gear 4. So like this lah, because dia F tangent 54 tu dia downward 54. Yang ini F radius always pointing to the center. F radius 54. So F tangent 54 is 8488 Newton. F radius what? F radius 54 is 8488 tangent 20 degree. Okay? Tangent 20 degree. Tangent 20 degree times 8488. So equal to F radius 54 is 3089.38 meter. Okay, so F54 ni already calculate. F tangent 54. Okay, sekarang ni at gear 4 tu, at gear 4 tu is not ideal gear. So all the gear is not ideal. So we have ini shaft. Tadi this is yang component is like this lah at the center, and this one downward, this one upward. Ini kita boleh namakan tadi apa? BX, BY, gear 3. Ini I boleh name it gear 4 B, CX or gear 4 CX lah. CX. But it's on the same chart, just labeling CY. So summation of FY equal to 0, you can make the decision. Your CX equal to 3089.38 Newton. Okay, CX summation of, sorry, just now fx0, summation of fx0, summation of fy0, you got your dy, the same as your tangent is, okay, yang ni kena letak direction is right positive. Ini adalah 88 Newton upward positive. Kena bagi direction apa positif. Okay, another thing kita have, pasal it's not ideal lagi this F tangent causing clockwise turning of your moment or your torque clockwise. So the counter react must be you kena buat sini your free radius is torque at, can name it just not torque at B, torque at C. Boleh torque at C. Okay, torque at C is the same lah. 305. You don't need to clear. Pasal total torque is 5. Actually is your F tangent time the radius is the same value at this one. This because kita bagi summation of torque 0.05 Newton millimeter. This is your torque C. Okay, the last one is about. Boleh lagi sikit lagi kelas. Okay, last is your gear 5. Okay, your gear 5. Your gear 5 tu macam mana? So this is your diagram, gear 5. So gear 5 terbalik of your gear 4 lah. Actually terbalik je. This is your gear 4. So your gear 5 is 90. This is much bigger. So this is your gear 5. Okay. So yang ni reaction. Okay. This is your quadrant. This is your shaft. Okay. Ini terbalik lah. Dia ni atas lah. Okay. Pasal gear 4 is driven gear 5. So ke atas. This one F tangent 4 to 5. Sama lah. Okay, and it always pointing to the center. F radius 4 to 5. And then we have, you can, okay, this is upward, this is downward. dy to the right, this one to the left. This is dx. And also F tangent for 5 ni produce clockwise turning of your moment or your torque. This one I go for. This one is torque. We label just now is torque D lah, torque D. So this our free program. Kena complete kan? This is not ideal here, so they have all this. Ada torque, ada reaction, ada center from the shaft, dy dx and torque. Okay, so you know F tangent 4.5 equal to F tangent 5.4 equal to 8.488 Newton. F radius 4.5 equal to F radius 5.4 equal to 3089.38 Newton. Okay. And summation of Fx0 dx equal to 3089.38 Newton. This direction, kita buat label the direction. Summation of Fy0, we have dy
Kau tengok
equal
waktu kita kecil lah tu. Bila semua macam bla bla
Newton upward.
baru tahu kan seronok
Okay.
kan.
Okay, top, okay, summation of top at D equals to 0. So this is point D lah, equals to point D. Top D
Kita dak behar.
equal to
Behar.
ni F tangent ni. F tangent for 5 times diameter of your gear 5 ni gear 5 and 5
Will you marry me?
is 90. Module is 4. Diameter 5, so this will be your diameter. Diameter 5, gear 5. Diameter 5 over 2. So diameter 5 equal to module times N5, 4 times 90, 360 millimeter, right?
8 ni.
So top D is
Habis yang
T
aku bagi
45 tu just now is
Kau dah tak boleh?
8
Kau
488 Newton
dah boleh?
360 over 2. Only top at D. Top at
Siap,
D.
baik dia member. Cerita apa?
So his top at D is 127,320 Newton millimeter. Okay, that will answer all the question for this part. Okay, we look last sekali top D, F tangent. Okay, one. Okay,
Aku suka tengok Doctor Strange in
Oh,
his
di-
girlfriend house.
apa apa 1.6.
Itulah best nak
Okay,
tengok baru
F-Tangent
banyak
4
aksi.
betul.
Banyak komedi orang kata.
3088 betul. 8488. Kenapa ni talk dia one ini pelik ni. Modul 4 mm times diameter is 90 360. Betul tak?
Betul tak? Ingat ni.
Oh ni kau pernah beli kan?
Aku beli.
Oh baik. Berapa ringgit sebulan?
Kelas
Kau beli Shopee kat?
3488.
Yeah, betul.
Are you with me or not? I think this is wrong betul tak? F tangent 5.
Terang buka ada.
F tangent 5 ni kan? Kelas. Hello kelas. Kan 8488 kan?
Betul.
Yeah, betul. I think so.
Yang lain is watching or not? Yang lain macam mana? Betul tak?
Tak pakai wifi ni.
F tangent F5. F tangent is 8488. Why did he put the F radius for the top?
Macam ni Kau
F radius cannot produce torque, right? Pointing to the center to the gear. Ni salah ni, So the answer is 127320. Okay? Oh, calculation method apa ni? F tangent 5 RPM 4. Okay. Um, ini dia tak salah ni. Dia take the value from the radius, not 3088. Ini ni, what I mean, if you look, the value that saya calculate, 8488, betul kan? 8488 times 360 over 2, 127320. Okay, class, understand Class? Alright.
Sedap tak tu?
Sayur
Alright, okay.
sedap tapi aku dah tak pakai.
Kalau, okay, another question is like this, guys.
Ada yang kereta lagi kan?
Ini yang saya cakap. Okay, this case, tengok ni. Ini macam mana pula?
Bila ada 5 star, pakai 5 star.
Ini I don't want to solve. Okay, if you attend yang this one I don't want to selesai sampai habis. Okay, this one they give the system. Okay, the middle shaft is driving. Input 13 horsepower from motor. They mean the middle shaft here is from motor 13 horsepower and the RPM is clockwise is 100 RPM. But it drive to one on the left. It drive to system. It drive shaft 2 on the left, and this middle shaft drive shaft 3 on your right. Okay, the power distribution is that 60% is delivered to shaft 3. It means only to the right ni 60% of the power. It means 13 horsepower. So 60% of 13 will go to the shaft 3. Okay, 40% of 13 horsepower will go to shaft 2. So you draw the free variable. You know, do you think you can solve that one? Boleh solve tak? Understand tak what I mean? So it means, okay, tengok okay, you go for shaft, okay, draw the free variable. Okay, tengok. You punya middle gear, okay, you have gear 2. Okay, this is your gear 2. If you look, can you see my live video? Gear 2, this is your gear 2. This is your gear 2 in the middle. So, okay, it turning clockwise. It's turning clockwise. Turning clockwise. So, it is turning clockwise. So, this is driving. So, this is driving. So, what is the direction on your left? Gear 2 to direction on gear 4. Gear 4 on your left. So, is it the F tangent from gear 4 to gear 2 downward or upward? Gear 2 is driving. Class.
Downward betul.
Awal betul.
I see, yeah, downward. So this is F tangent 4 to 2. Tengok pasal dia left. Okay, 4 to 2. Procedure is the same. Okay, this will be your shaft. Let's say kita point A lah. So we have, ini adalah, pasal this dah, okay, this will be F radius always pointing to the center. F radius 4 to 2. But the first thing we need to find, what is the F tangent 4 to? Okay, let's say this A, shaft A. This is a Y, a X to the left. AX F tangent 42 ni produce counterclockwise turning of your moment or your torque. So yang ini go for clockwise. So ini adalah torque at A. So this will be your free body diagram of your gear 2. But our starting point, that F tangent 42, okay, is given that horse power. Okay, be careful. Look on your note. This is English unit. This one English. Betul tak? Because it's horsepower lah. 13 horsepower. tengok the notes on your ni. For power, for English, nampak nampak tak? English power H right is F tangent time V over tadi yang kilowatt FT times V only, but for power for English horsepower is FT times V over 33,000. Your V2 in feet, your V2 in feet per minute. Okay, they already done the conversion. Your F tangent 2 will be in pound force lah, pound force. So it means that okay, it says that okay, the 40% of this power, and 40% to your right, but 40% to your 60% to your right, 40% to your left. To shaft 2 is 40%. The remaining, the remaining apa? Okay, 40% of the power is there to shaft 2. I mean to the 40% of power is delivered to shaft 2. To your left ni 40%. So 40% of this is given that this one is berapa tadi? 13 horsepower kan? 40% of 13 berapa?
Maksudnya kau belum tak sesuai lagi nak jadi bapa.
Aduh. Aku dah bawa dia bagi kat
5.2 horsepower kan? Okay, 40% is 5.2 horsepower equal to FT. Because we need to find this FT42 lah, that's FT. This is F tangent 42 times B over 33,000. Okay, this is English unit because your is feet per minute. So your V, we need to find V. Once we know V, we know this is 5.2 because 40% to your left. So you can get your ni lah. Tapi we need to find V. V we can calculate, right? V. Okay, V is, if you look on the, from your notes or your PowerPoint, V is for English, V is pi dn over where? Tadi metric pi dn over 60,000 kan? Pi dn over where your diameter will be in inch, right? Okay, in inch, and n just now it's mentioned that your n is, your question, your n is 1000 RPM. Okay, n already 1000 RPM. Diameter ni, okay, we need to find diameter of your gear, this gear. Your gear 2 lah, gear 2. Ni pi D2 N2. Okay, N2 is 1000 RPM. D2 ni, diameter 2 ni, we know that diametrical pitch is, jadi module is M, module is D over N. Diameter is N over diameter. Okay, diametrical pitch is given in this question. Diametrical pitch, all diametrical pitch is 6. Is 6. Okay, diameter equal to N2 over diameter G2 or N3 over diameter G3 and 4 over that is diametrical pitch is 6. So diameter of your gear 2 is your N2 over diametrical pitch. So it means okay, diameter is N over P lah. Diametrical pitch is 6. So your diameter of your gear 2 is N2. Your gear apa? The tip of your gear 2 N2 is 18, right? 18 over diametrical pitch is 6. So 18 by 6, so you got your diameter apa? 18 divided by 6, so your diameter is 3 inch kan? Oh, sorry, 3 inches. 18 bagi 6, 3 lah, 3 inch. So diameter of your ni, you know, is diameter is 3 inch. So we know diameter, so you can get your V. Understand? Are you with me or not? So your V is pi times 6 inch times 1000 RPM over your 12. So your V is in feet per minute. V is pi times 6 times 1000 divide 12. So your V is 1570.
3 doktor bukan 6.
Oh, sorry. 3 kan?
dalam buka tu.
3 kan? So we got is 785.4 feet per minute. So bila you know your V, okay, feet per minute, so you know yang tadi horsepower 5.2 equal to ni lah. So you, from this equation lah, so you know your FT42 equal to 5.2 horsepower times 33,000 over your V, kan? Over your V. V is 785.4. So your F tangent 2 pound force, So 5.2 times 5.2 times 33,000 divided by 785.4. So your F tangent for 2 is 218.5 pound force. Ini English, pound force. Kita tengok solution. Oh, dia tak bagi solution ini Tak ada. Dia tak bagi solution. Ada ke? Solution tu ada. F tangent. Tu betul lah. Kalau kita tengok solution 218 F radius, F tangent. Then only you can solve lah. Saya tak solve pasal boleh buat faham kat kelas Hello kelas.
Yes, betul.
Bila you know F tangent, then you buat your program F radius for 2 is F tangent for 2 tangent phi, and phi is given. Ini mesti given. Phi is 20 degree. Okay, 218.5 tangent 20 degree. So that's why you look on the solution, nampak You look study on the solution. So this one F radius tangent phi 79.8. This pound force. Torque is kali ni 0.5 the radius. Radius because this is diametrical thing. Diametrical is N over D. Procedure is the same. Nampak? Okay. Now the gear 3. The gear 3 nampak tak? The gear 3. If you look yang tadi question, gear 3 pula. If you look gear 3, okay, at the back there. Okay, at the back tadi is not in front is your gear 2, right? Your gear 2 at the back is now. Ni is gear 3. Gear 3 ni also same 18 juga 18. Okay, this is clockwise turning and this is driving. So this is driving. So gear 3 reaction from gear 5 to gear 3 macam mana? Tadi gear 4 to gear 2, now gear 5 at the back. This is driving and turning clockwise. So it means reaction is to up or what? This is your gear 3. Gear 3 class. Gear 3. Hello class. Are you watching now? Gear 3 kan? Turning is clockwise, driving. So reaction from gear 5 is it up or down? Gear 5 to gear 3. F tangent 5-3. Downward or upward? Right, yang ni drive. It is yes, upward. Pasal gear 3 is driving. So reaction from tooth of your gear 5. So this is F tangent 5 to 3. Tapi be careful, 5 to 3. But it is said that okay, yang this one you cannot summation of torque is 0. No, cannot. Pasal in this kalau normal case memang transfer is macam just now yang previous example that we discussed just now is the pure transfer of power. But this one they divide, nampak tak? F tangent ni, this one will not produce. It's not the same torque as the gear 2. Understand tak for this case? Because it says it's transfer 60% power here. Clear tak kelas? Power just now is 13 kan? Power is FTV. Okay, ni FT ni F tangent 53 lah. Okay, time V 53 ni kita boleh calculate over 3,000. Yang ni is okay kelas, saya bagi laluan azan sekejap je. Hold on je for 1, 2, 3. Okay, kelas. Are you there? Kelas, kita sambung balik sikit lagi. Okay, kelas.
Ya, ada.
Alright, okay. Yang okay, calculate ni sekarang ni kita kena reaction of. Okay, just now gear 2 tadi I tak. Kalau if you look on the draw figure and calculate all forces, draw figure for every gear. Tadi gear, I'm talking tadi gear 2. Actually for gear 2 then gear 5 pun no problem lah. Gear 2 and gear 4 tadi is terbalik je lah. So I just want to tadi gear 4 on your left, right? Gear 4 macam tadi lah. So you have tadi gear 2, F bar, F, F bar. Ini gear 4 just now. Gear 4 pun you kena finishkan juga tadi. Just now escape. Gear 4 is F bar 2 to 4. Pasal tadi yang gear 2 F ni downward, right? Downward. So yang ini upward lah. Okay. From gear 2 to gear 4. Pasal gear 2 is drive. So this one F tangent to 4. It's the same value, same value. So you can know what is the reaction of your ni lah. This will be your BY. Ini I tak payah sudah lah. You boleh dapat BX. And also ini boleh dapat what is the torque. This one produce counterclockwise torque. Okay, be careful. Ini diameter gear 4 ni you kena cari. Diameter gear 4. Ni F ni produce your punya turning of your torque is, or your moment is counterclockwise. So this one we will go for torque at B will be clockwise. I think you know how to find it. Okay, you can solve for gear 4. Just now we are discussing about gear 3 just now. Yes, gear 2. Because gear 3 here. Okay. Gear 3.
Dia cakap the speed of both output shaft have been reduced by 3. Is it mean the N4 and N5 actually is equal to 333.33?
The frequency of again also calculate all forces and torque if the speed of both output shaft have been reduced by 3. Right. If the speed of output shaft have been reduced by 3, yeah, because if you look on the speed ratio, yeah, the number of teeth, yes, the number of teeth is not given, right? That's my point. Sorry, gear 4, you're right. To get the diameter 4. The number of teeth is not given. Understand?
Yeah.
So gear 4, it means N4 is not given. So by the statement that reduced by 3, it means it's the speed reducer. So we know that is N2 just now is 18, right? N2 is 18. N2 is 18. So okay, for us to calculate for our torque, right? We need diameter 4. So we know that diameter pitch is given is 6 is N over D, N4 over diameter 4. Again, so if you know number of T, of course we know diameter 4, but even the number of T of force is not given, but its shape is reduced by 3. Okay, so to get the N, we know that N last equal to N first. This is our speed ratio. So our E is 3, right? 3, because this is N last, N4 is faster or reduced?
Diameter is higher, so it should be reduced.
Okay, just see what is our formula. N last, you mean your N4. So N4 equal to N2 because the driving is 2, right? It is turning like this, clockwise like this. So N4 turning this counterclockwise. This will be your N4. So what is N4? N4 is reduced by 3, right? So it means that it means N last 1 over 3 N first, betul tak kan? Plus last is 1.
Yeah. I think we should step the E, right? We should step the E.
Okay. Yeah. That's my point. Yeah. E is what is driving is what N2, right? N2 driven is N4 equal to 1 over E. Okay. So N4 N2. Actually, you don't have to calculate it. 1 3 you times the number of teeth of year. Ini just theoretically I explain to you. Okay. But if you
So the,
smart enough,
since the power
you
has
just
changed,
time 3 the number of bits.
since the power is changed from 40 to 60%, something like that. So, but the RPM is still same, right? RPM, the run per minute, the 1000 that one, it's still same, right? There's no change.
Yeah. The speed, the input speed from gear 2 and gear 3 on the same shaft is still 1000 RPM. But the shaft on your gear 4 is reduced by 3. Yeah, 1000. So apa the reduce of speed by ni lah. So it means you punya N4 is 3 and 2. Simple saja. Kalau reduce by 3, so the bigger the gear, the slower the speed. No, I mean I'm talking about the shaft too. The bigger the gear, the slower your speed reducer. Your gear 4 is much bigger than gear 2. So it means kalau you are smart enough, you don't have to select this theoretically. So N4 is 3 and 2. Actually, kalau reduce by speed, you punya number of teeth of your gear 3, gear 2, 18 times 3. 18 times 3 berapa? N4 is 3 and 2. 3 and 2. So berapa? 3 and 2 is 18. That will be your number of teeth of gear 4 pasal you reduce speed by 3. You times 3 aja. Understand tak?
Doctor, so nanti kita calculate gear 3 and gear 5 is also
N4
same
is
method, right?
54. Yeah. Okay, I'm talking about gear 4 first. Be careful lah. Gear 4 tadi because dia cakap speed reduce kan. Because N4 is not given, but his statement speed reduce by 3. So it means your 18 number of teeth times 3 lah, 54. So your number of teeth of your gear 4 is 3 times bigger than the number of teeth of your gear 2. Itu saja. You speed reduce by 3. Clear or not? So if you know your N5, of course you can get your diameter 4 lah. Because we know pitch, we can go to calculate for our top at B. Can top B is F tangent time diameter. Diameter we know diameter 4 is N4 over diameter pitch. So diameter 4 is N4 is 54 over 6. Itu lagi nak. Yang matematik 9 kali 6 54. Okay. Diameter is 9 inch for your diameter 4. Understand tak kelas?
Yes.
Then you can get your top. Then you calculate your top. Sometimes question is tricky. Tapi itu itulah. You kena check calculate betul-betul. Dia cakap reduce by 2. So we can get 4. Okay, about the gear 5 just now. Okay, gear 3 and about the gear 3. Okay, gear 3 at the back. Okay, power tu F353. Okay, is okay. F force from the gear 5 because it's rotating clockwise, right? So it means reaction from the force tooth of gear 5 to 3 is upward lah. So to get that F tangent F3 ni, be careful. It's not the same torque. It means the torque is not the same as your gear 2 just now. It's not the same torque as your gear 2 just now. I pun tak selesaikan gear 2 tadi kan, the torque kan. I just explaining to you what is the FT. It's not, I tak solve kan your FT tadi kan. Betul tak? You know how to find the correct kan? I just explain to you. Gear 2 just now, your F tangent for 2 ni. I mean, torque A also you know how to find it. The torque A ni for your gear 2 just now, your FT for 2. F2 times diameter 2 over 2 lah your diameter ni. Diameter is because P is N over D. Diameter is N over P. So you can get diameter ni. This is diameter pitch. So you can get torque A. Tapi the torque A at gear 2 is not the same as torque at the back. Remember yang previous example is the same. Normally it's the same because it stated that 60% transfer to of the power. It's not the same. Because the power 40% to the left, 60% to the right. Pasal dia divide, dia divide by 2. Main power 13 horsepower divide by 2. 40% to the left, 60% to the right. So 60% just now. Jadi for your gear 3 just now, okay, 60% of 13 horsepower is berapa? 0.6 times 13, bro, is 7.8. So it is 7.8 horsepower. Understand tak, kelas? Hello, kelas?
Yes, yes.
Boleh buat lagi sikit ni? Boleh, kelas? Understand tak? For gear 3.
Understand, Oda?
So we need to find what is V to get. But the point is for us to get FT53 lah. Because FT time pitch line velocity is the power is 7.8 because it is 60%, not 13, 60%. So to get, we need to find V. Your V, okay? We need to find your V. Your V, pitch line velocity at gear 3 is apa equation ni tadi? Pi diameter gear, this your gear 3, this your diameter gear 3, big pun not gear 5 because kita pre-border gear 3 times RPM of your gear 3 is the same tadi as gear 2, 1000 RPM. This is 1000 RPM, okay, RPM diameter 3 over 33,000, 33,000. That's your will be your V. Okay? Sorry. Apa saya? Over 12, sorry. Ini B, sorry. Over 12, Over 12. So, pi, okay, diameter 3, bro. What is the diameter 3? Diameter 3, bro. Gear 3 punya diameter berapa? Since given your diameter ke pitch is 6, kan? Okay, your pitch, diameter pitch is N over D is 6. So, diameter 3 is N3 over P lah. So N3 berapa? N3 is 18 over diameter 3 is 6. It's actually the same lah guys as your diameter 2 just now. It's the same. Tak payah saya calculate the diameter 3 because the same this number, right? Diameter 3 is same as diameter gear 2 is 3 inch. So it's a 3 inch, 3 inch times 1000 over 12. So it's the same lah. V is 785 is the same. Because the same actually our V of gear 3 and gear 2 is the same. You don't have to calculate feet per minute. So tetapi the different that our power is 7.8 lah. Tadi yang to the left 5.2 horsepower ni is 7.8, 60% of your 13 horsepower. So you got your V lah. From here you can get your V.
Ulang gaji ni.
Where you punya V is, so your F tangent 5 to 3 equal to 33,000.
Ni 3 jam kan saya kali
30,000 times 7.8 horsepower over your V, over your 785.4 feet per minute. Okay. So F tangent tadi tak calculate F tangent ni. I already calculate F tangent yang dekat gear 2 dengan 4 tadi. F tangent tu is 218.5 kan. Okay. Ini cerita yang for gear 3 to gear 5 F tangent is divide 785.4. So this will be force F tangent 53 equal to 327.73 pound force. Plus, boleh bawa So F radius sama. So F radius 53 is 73 tangent
Siap menang ke?
20 degree.
Malah sama main game, bosan.
Kan?
There's goes my little girl walking with the troublesome.
So F radius 53 is 119.28 pound force. Okay, so you punya free body diagram tadi. So your free body diagram yang ni of gear 3 tu. From gear 5, so you have F tangent is upward. F tangent 53 is ini, this value 327.73 pound force. Ini dia to the center 119.28 pound force. Okay, satu yang kena adalah yang ni we can label it A, B, ni CX, DY, and also ni produce counterclockwise of the turning to your moment or your torque counterclockwise, so ini will go counter react, will be your torque at C. Okay, remember yang sama lah diameter is, just now diameter is 3 inch. So unit CX equal to yang ni lah 119.28 pound force is this direction. CY is 327.73 pound force downward. Torque at C is F tangent by 3 times diameter, this is diameter gear 3 diameter 3 divide by 2 sama dengan 327.73 times 3 divided by 2, 1.5. So that will be a torque at C. Equal to 491.6 pound force inch, torque pound force inch. It is checking. You boleh tengok lah all the solution kat sini. Diameter 3, 81, top 3, top 3. Year 3. Ini saya tengok solution mana ni, question 2 Year 3. Yang tu tadi betul saya calculate kan. Check 218.5 betul. Yang for gear 2 right, FR is yes 218 top betul. Okay, gear 3 why is it not the same? Mine F tangent to, because it said that it is 60%. Be careful guys about the solution pasal ada conflict Guys, are you with me or not?
Yes, correct.
Tapi you look on the solution, dia cakap F tangent 3, F tangent 3, ini gear 3 punya free body. Diameter of gear 3 is 9 inch. Diameter of gear, ini soalan mana saya tengok ni? Betul ni kan? This one kan? Okay, ni gear 3, sorry. Oh sorry, ini gear 5, my mistake. Okay. This gear 3, betul lah apa saya buat ni? Gear 3. Betul lah. Top. Betul? Top. Top C. F tangent. F tangent is 327. Okay, 327. 0.5 diameter. D2 is 827.7 times 0.5 or 0.5 of diameter 2. Why is 3 over 12? Oh sorry guys, 3 over 12. Okay, kelas, sorry guys. Force. Yeah. Kelas, be careful, take note. About ni, be careful, my mistake. Pasal you punya, kalau you look the solution, dia divide by 12 because you punya D is 3. We are in, diameter is in inch, right? Top is pound force inch. Because our diameter is in inch. Kenapa dia divide by 12 ni? And someone boleh ni tak? Can someone help me kalau siapa yang focus on this? Oh yeah, dia pound feet. Saya pound inch, no problem. Ni pound feet, no problem. Saya, that's why I got inch. Make me confused. Ini pound feet, of course lah, in feet. I mean, mine is pound inch. Okay, clear tak class? And gear 5 class. So this is your gear 5. Then your your gear 3. So gear 3 you have top already get it. So your gear 5 is the reverse of your gear 3, so gear 5 is like this. So this is your gear 5. So this is your gear 5. So yang ni you punya F tangent 3 to 5, and this direction is F radius 3, 5. Okay, yang ni you have tadi apa, D. Ni D lah, yang ni D is your dx, D is your dy. Okay, F tangent 35 is the same value lah. 35 is the same as F tangent 53 is 327.73 pound force. F radius 35 equal to F radius 53 equal to 119.28 pound force. And this one produce counterclockwise, ini clockwise direction of your top D. Okay, your dx equal to sama lah, F tangent 327.73 pound force this direction, and dy equal to 119.28 pound force outward direction, and your top D equal to your F tangent 35 times, okay, this is diameter 5, you can forget diameter 5. Okay, diameter 5 over 2. Okay, diameter 5 over 2. Okay, diameter 5, remember tadi yang speed ratio tadi kan, sama lah tadi yang 4 kita dah saw, it mean 4 and 5 is the same value, so dia punya diameter of 4 and 5 is the same, pasal reduced by 3. Your diameter 5 is the same, apa tadi is berapa kita punya diameter 4 punya ni, so is 54 kan. So N5 ni, so diameter 5, since diameter 5 is N5 over diameter ke pitch. N5 tadi sama dengan diameter 4, 54, pasal reduce by 3 over 6. Diameter 4 tadi, so diameter 4 is 9 inch lah is 9 inch. Diameter 5 is 9 inch, so your top D is F tangent 327.73 pound force times 9 bagi 2 kali radius. Okay, 327.73 times apa tu 4.5, 1474 is 1474.8 pound force inch. Okay. Okay class, boleh I hope you understand, boleh class? Is it okay? Ada question tak before I quit? Ada apa question?
For the B, doctor,
Yeah.
for the part B, is it asking for how the N5 if T1 equal to T2? T2 equal to T3, right? So I see the answer there is 18 over 72 and 18 over N5 omega 2. Is it Y?
Calculate N5 if top on shaft 2 and 3 is equal and 4 is 70. Okay, it means tak ada, kalau top equal, it means tak ada, there is no 40%, 60, 100%, it means 50%, 50%. 50%. This one 50%, this one 50%. Sorry. Okay, calculate N5 if top on shaft 2 and 3 is equal. Because top is power is top times W, right? You can angular speed. So calculate N5. What is the number of teeth of gear 5 if top of shaft 2 and top on shaft 2? This shaft 2 and shaft 3. Is top on shaft 2 and shaft 3 is equal, and N4 is 72. It mean the top on shaft 2 and shaft 3, mean this top and this top is equal. Calculate N5 if top on shaft 2 and 3 is equal. It mean the top ni is equal. It mean the top ni is your F tangent time the radius of this one is equal to, this one you have this one, you punya F tangent time radius 2 ni is your torque, right? Okay, that's your torque value. Okay, torque. And your F tangent is the same value time the radius ni. The summation, the torque is equal. So it means F tangent remain the same.
Because I see the answer is using P equal to T omega and then T2 equal to T3. But I don't understand is how he using the number of P's over there, the omega one. The 18 over 72 and the 18 over N5 that one.
P is diametrical. P is your, what is P? P is
Power.
Oh, I thought it's okay. P is power times time. T times what you call it, W, right? It's power.
Yeah. The omega should be the revolution per minute or something like that, right? So it's equal, right? But how the number of T's over there, the 18 over 72 and 18 over N5 that one, I don't understand that one really.
Yeah, okay. It's stated that 40% to the left, 60% to the right, right? 0.4, yeah, this is a solution. 0.4, you mean 40% is on your right, on your left, on your gear ni, on your gear 2. Sorry, shaft 4, gear 4. It's transmitted. So it means if the torque is the same, yeah, it's like this. This is how you solve it. Torque is P power over W.
Okey, makanan kau di mana?
And it's the same. So it means 0.5 also and 0.6. It means that it's the same value. Is the same. So you can get your N5 from it. It's just 0.4 means 40% of the power. This one is 0.6% of the power. Okay, W is this one. W is your N, small n into the speed. And apa tu yang ini 18 over 72. 72 is your, which one is 72? Which shaft tadi yang
N4
N4 is 72. So N4 is 72. So it means yang what 18 tu your can you know that this one is your gear train kan? Speed ratio kan?
Yeah, speed ratio. But I don't understand is why speed ratio you need to time the omega 2.
Because the ratio 18 over 72. Okay, 72 is the N4, and the ratio 18 over N5 times your omega 2, and because omega 2 is the input speed. Actually, this is not the name of omega. It's already my mistake. I said UPP is omega. This is not we call omega. Omega is what we call W. Ni W. W is the input speed, and the input speed is remain the same. Okay. W2 is your input speed. Your this is your output speed. Output speed. This is the speed of your gear shaft 3. This is the output speed of your shaft 2. That's how they solve it. Then you can get the N5 over 38. This is one way to solve it. Clear or not? I know. Yeah, I said why is 1872 times this W2? This one also times W2. Remember your E. You punya. This is your output speed. Output speed. Remember your E is N2. You punya your drive is N2 kalau on your left, N2 over N4, right? N2 over N4. So you punya N last, you punya N4 equal to N2 over N4. You punya N first is N2 lah. So that's the ratio. N2 is 18. This one is 72. Understand? Ni W2 lah, N2 is W2. Clear or not?
Oh, okay, understand.
Yeah.
So he want to find N4 and N5. At the end, seeing the omega is set, so he just use the W2 on this guy.
Yes.
Okay, understand. Thank you.
Okay kelas boleh Okay kelas. So good luck for your exam.
Doktor,
Ya.
tu test malam ni boleh pakai ni ke? iPad.
Pakai kertas lah, jangan read the instruction they ask you to do effort.
Dah, alright doktor. Thank you.
Anything lo. Kalau yang nak pakai iPad, macam you dah biasa ke pakai iPad?
Betul doktor. Sebab ada section boleh pakai iPad.
It's up to you lah. Tapi you read the instruction, boleh tak? Are you allowed? Macam mana you submit nanti? Bila you nak submit nanti PDF, no problem kan?
Hantar PDF lah.
Tak, my comment is apa yang you used to. Itu je. Yang you better buat. Takut iPad tu lagi problem ke, jangan lah. You better use secara traditional lah.
Sebab sebenarnya iPad save masa ni.
Betul doktor.
Gambar. So mungkin biasa kita save 5 minit untuk buatkan soalan ni.
Kau buat pakai iPad lah selalu. Canggih lah kau.
Selalu.
Saya pun buat.
Saya tak tahu pakai iPad macam apa boleh pakai iPad. Kalau iPad lah, no problem.
Upload je lah. Lepas siap upload PDF kepada Drive. Lepas tu download dari Drive. Upload lagi kepada
Tapi
email.
ya, boleh. Boleh kan? Instruction cakap tak ada kan? Kalau boleh.
Kita cakap A4 size. Tapi iPad biasa bukan A4 size. So, kalau kita cakap boleh, memang guna iPad je lah boleh. Kata.
Dari tengah nak lahir anime
Ada
kejap.
section boleh guna doktor.
Minta kejap je lah. Nanti aku share.
Boleh lah.
Boleh,
lah. Kalau yang mana you used to itu je.
Okay, thank you doktor.
Submit PDF PDF.
Okay, saya doktor.
Doktor, tadi je, itu test 1 punya question dia sudah send ke nanti baru send?
You read the instruction. Tengok, saya tak apa instruction tu dia cakap at what time. Your test will be on what? Bila pukul apa?
Pukul 8 doktor.
Tak read the instruction guys. Jangan depend kat saya. Saya pun tak baca sangat instruction. You guys yang you have to read. Pasal you are the one taking the exam, not me. Read instruction. Saya hanya menjaga. Saya hanya pantau saja.
Dia main industri punya
Okay.
unit
6
lah.
Okay. 6 PM.
But they already 5 right? 5 o'clock. At 6. Plus, everyone is listening or not? You kena read. 6 PM you will receive email. Your graduate email. Open your email. Okay, 7:30 you join WeBAT. WeBAT meeting session. Tahu kan?
Kau tak nak jawab ke bilik aku?
Ya, doktor tahu yang
Kau boleh ke bilik aku kan?
Email they give you the
Orang
link for
tengah
WeBAT.
kelas kan, kau tengok sibuk
I tak nak nanti I cakap nanti konflik dengan ni. You baca the instruction, everything is there. Dia dah clearly dah already state. 7:50 password will be released. Will be shown
Ya,
on
dekat
your
ni.
Google Docs link. 7:50 and 8 you start answering question 1. Kemudian you punya answering question from 8 to 8:55. At 9 PM, sharp at 9 PM, password for question 2 will be released on Google document link. Google document link ni will be, you tahu kan?
Besok nak test. Let's fucking go!
yes, doktor. Yang ni dah biasa.
Dah biasa kan? I think biasa kan pakai Google platform kan? Pakai Google. It's
Sebab
the same
dulu
lah.
punya exam semua adalah bagi question sebelum mungkin pagi-pagi ni ke semalam ke, so confused sikit lah. Tak nampak
It's
6 PM tu.
Ya. Kita langsung tak, we will not use e-learning tau. We will not use e-learning as your platform. Everything is on your Google form, Google document. Google document. Kalau katakan you have problem, katakan jangan send me first. Katakan you have dah tak boleh, you send me to my new email. Nanti I give you email. But do not send to my email. Send to Google ni. Unless you are ada critical case. Understand what I mean?
Understand, doktor.
Try to submit all Google. Nanti dia kind like not following standard, nanti susah. You punya question will be lost. Kata you, I cannot check. Tapi only yang special case yang tu you send to my personal mail. Tapi jangan submit because only yang special case will you submit to my email. Email tu I will give to you for yang critical student saja I give the email. Alright? Not for all of you. Okay kelas?
Okay, doktor.
Alright, okay. Okay, good luck for your exam. Okay. Alright. Okay. Attendance boleh attendance. Assalamualaikum warahmatullahi. Sekian tanya. Good luck ya Azan.
Section 8 kena scan juga ke doktor?
Boleh campur, boleh.
Okay.
Buat apa kau tes?
Ha?
Tes kau
Tak apa-apa.
asal kau tahu?
Bismillah.
9. Sangat apa? Asal kau tahu?
Ni. Ada kau nak tolong aku? Tak ada kan? Diam. Let's fucking go.